Hi all, hope you are doing well. We are starting with the DataBricks series, DataBricks playlist here. Okay, so welcome to video one. The title of video one is why DataBricks. Okay, so I think before we start learning DataBricks, I thought it is very important to let you all know why we are learning DataBricks, right? What are the features of DataBricks, right? And what is the importance of DataBricks in today's world, right? And that's the reason I think before we go into Databricks, I thought I should make the first video where I'll tell you why we are learning Databricks. It should not happen that some of your friend is learning Databricks, or you know your company is using Databricks or something like that. What is the reason? We should be understanding that, right? So let's not delay. We will quickly start. Before we go into technical, I want to give you one simple example that we face, like think IT engineers face that in daily lives, right? I have come up with some example. Let's see if you understand. So the example is, let's say the company has got one project. Okay, there is one project that company has got. They're estimating that one person with, let's say, 1 lakh salary, 1 lakh per month, right, can complete the project, can complete the project in, let's say, 6 months, right? Excuse me for my voice, I have little cough, so might possible in between I might, I might be coughing. Okay. Okay, so this is the scenario. The company is estimating that one person can complete the project in 6 months. Okay, and company has charged, let's say, 20 lakhs cost for this project, right? So company is estimating that they will complete the work in 6 lakhs and they'll, get some 40 lakhs profit, right? That's what they are estimating. Okay. This is the simple estimation that organization has done. Okay, we'll go through little drawings and this stuff so that you will understand it better. So let's say this is the person, I think, having 1 lakh salary. Okay, 1 lakh salary, right? He is the whole and sole responsible for this project, right? He will start with the project, he will develop the project, right? And he will code also, like everything for this project this person will do, right? Now, okay, now uh, I want to tell you what are the advantages and disadvantages of this way. Like company is hiring only one person, having 1 lakh salary, right? And they are estimating this to complete in 6 months. Okay, so company, it will cost how much to this organization? Let's say 6 lakhs, right? As of now, it feels like the cost of the project will be 6 lakhs, right? um, we are just putting the cost of employee, that is who is going to work, right? uh, the management is going to be very easy. There is only one person, right? So I would say easy management. Okay, because it is only one person, there is nothing much to manage. He will manage himself, right? And he will continue with the project. So easy management is there in place. Then if there is some issue, I think this person is responsible. If he completes, he or she completes, he is the responsible. If not, he or she is the responsible, right? So simple management, simple structure, right? And these are the pros of this project, pros of hiring one person, right? Now, next thing, there are few scenarios. For example, if this person gets overloaded, right, this person might get drained, right? So what may happen, maybe this person can get sick or something like that. Okay, he might get overdrained, he might get sick. Okay, sick. Okay, and maybe 6 months time is going to, let's say, 7 months. Okay, because this is the only person responsible and no one has no, like no one has idea about this project, right? Only person working on this project. Now, next thing, I think this person, let's say, within the 6 months, right, this person tries to, let's say, resign, right? He is not feeling right here. He is getting overdrained because he is whole and sole responsible for the project. Might happen, he will responsible, he might resign, right? So first thing, the first issue is no backup. right? There is no backup to this person, right? Who will backup? There is no backup, okay, as such. Whole and sole dependency is on the project, right? And if this person is not available, right, project is on hold, right? For example, this person has some function or something like that at his home, right? So there is no backup, and whole and sole responsible person is this one, right? Now if he tries to resign, company will have to hire same person having salary, let's say 1 lakh. They are trying to hire same person having salary 1 lakh. This person, let's say, worked for 3 months, right? And now he is going to serve 2 months of notice, okay? So 5 months this person is going to work, and another person is going to work for, let's say, 3 months, right? So this project will cost, let's say, some 8 LPA to the organization, right? And again, the new person coming is fully dependent on this one, the earlier one, right? There are few, I think, disadvantages of hiring, let's say, only one person with 1 lakh salary, right? Something like that. Now there is next scenario. Current basically the current projects work like that. What another organization has done, they also have got, let's say, same project, right? Same estimation, same things. They have hired one person, let's say, having 1 lakh of salary, right? He is having 1 lakh per month salary, okay? Now the thing is, company is not asking this person to work fully on the project. What they have done, they have hired another, let's say, 4 people. Let's say 1, okay, 2, okay, then 3, right, and then 4, okay, each having, let's say, salary 50,000, 50K, okay, we'll put it as 50K, okay, 50K, each is having salary 50K, 50K, right? Now the 6 months of work is getting divided in between these people, right? So let's say 50K, 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 they are doing some work, right? They are, let's say, full FT to the project, full in the project, and 1 lakh person is 50% in the project, right? So the 6 months project will get completed in 1/5 of time, right? 1/5 of time, as in, let's say, 1.5 months, maybe we can call it, okay? And all these people will be working under this person, right? Working under this person, okay? Sorry, that is the scenario, for example, okay? Where is the line? Okay, this is the line, right? Working with this, right? And working under this, right? So they'll be, let's say, now here the things are, company is planning to complete the project in 1.5 months, right? What will be the cost here for 1.5 months? Let's say, let's consider 2 months, okay? 2 months, okay? So 2 months, 50, 51 lakh, 2 lakh, and let's say 2.5 lakh, because this person is 50%, right? 2.5 into 2 is what? 5 lakhs, for example, right? 5 lakhs is going to be the cost, okay? Now the idea here is, let's say this person gets sick or something happens to this person, right? The company tries to hire, let's say, new person in place of this one, right? So here there are 1, 2, 3, 4 person, right? 4 employees are there who can guide the newly hired, right? And he can quickly start working, right? So there is clear backup in place, okay? Backup in place, right? First thing. Now second thing is, the what I can say, the work is distributed, okay? Work is distributed, okay? Distributed, right? So nobody is going to be kind of frustrated or something like that. People can take the leaves and all that stuff, right? Our we had earlier, I think, some 1.25 months it was taking to complete the project, but we kept it 2 months. That is fine, okay? So work is distributed, people are working like this, there is complete clear backup in place, okay, and the system is hard to manage basically. The reason being, this is the one person, okay, there is hierarchy, this one person will manage this four, right? If something goes wrong with this four, right, this person will be responsible, and whatever, I would say, the results of these four people, whatever work of these four people, this first one, this, I would say, leader one is going to represent, okay, and he is 50% over here, right? He might be 50% in some other project, okay. He is kind of, let's say, technical lead, right? So clear cut, I would say, advantages what we are seeing here is the backup clearly is in place, work is distributed, hard to manage, the system is hard to manage, and also it is cost efficient, right? Cost efficient, we are completing the work in 5 lakhs, let's consider that as 6 lakhs maybe. Cost efficient. The next thing is, it is fast, let's say, getting work done fast. For example, we can say getting work done fast, okay. Here it was taking some let's say 8 months for this project to complete. Here the project is getting completed in 2 months, so getting work done fast in this case, right? Because here work is distributed, okay. Here work is not distributed, okay. Fine. This was the scenario. I think these are two things I wanted to, convey you. Based on that, we are going to learn the history of data engineering, I can say. Okay. Fine. So I would start with, there is first thing. There was first thing called monolithic systems. Okay, monolithic systems, right? So in this start, the date, I think the engineering work or data engineering work was going to, what's happening in monolithic systems, okay. What are monolithic systems? Basically these are the systems, single system with, I would just write here, single system with all parts tightly coupled, with all parts tightly coupled, okay. If one, let's say, if one part breaks, the system will fail. It is like one big system like this, one big system like this, it has all the power, right? Okay. Now earlier, the this was the kind of software that was existing, where entire user interface, entire business logic, data access, right, everything was stored as one single unit, right? It was kind of a monolithic system, a big, let's say, one big system holding full power, holding full power, right? Now we have seen, if this person is to be replaced, what organization has to do? Organization has to hire a new person, right? So they have to hire a new person, right? In our, let's say, I would say, IT world, this is called vertical scaling, right? This is called what? Entire vertical they are going to hire, right? So vertical scaling, vertical scaling, right? It is vertical scaling, right? Vertical scaling, as in, there is one more meaning to vertical scaling. If they want to put a backup, they want to put the same system like this one. And vertical scaling, as in, let's say, if this person tries to resign or something like that, what organization can do? Organization can increase the power of this person, can increase the power of this system. Let's say you are taking 1 lakh, now you take 1.25 lakhs, right? But though this person takes 1.25 lakh, this person is going to work with same efficiency, same thing. This is going to add a cost, right? So vertical scaling, okay, is not time efficient. Vertical scaling, let's say, is not time efficient, right? Is not time efficient, is not cost efficient, right? This is the example of vertical scaling. Organization, let's say, 1 lakh, you take now 1.25 lakhs, right? Similar way, let's say we have some server, we have one server, okay, let's say of some x capacity, right? And I want to scale this server, let's say vertically. What I can do, maybe I can increase the capacity of this server x into 1.25, right? This is called vertical scaling, okay. And the hiring another one is called horizontal scaling, right? So to get the backup for this monolithic system, organization has to bring entire another system, right? Because vertical scaling is not time efficient, not cost efficient, right? This was the disadvantage of monolithic system, okay. Everything was on one system. If that system is going to down, if one part is going to break, it will break entire system, okay. So what are, let's say, we will understand the pros of monolithic system. Simple to develop, right? Simple to develop and handle, right? That's the first thing. Then easy to, let's say, debug and test, right? This is only one system, right? Only one system. Whatever is going to happen is within this system, right? So it is easy to debug and handle the issues, okay. These are, let's say, pros. And cons are the first is like non-efficient scalability, we can say, right? Non-efficient scalability, okay. Then next one is hard to maintain and upgrade, right? Upgrade as in, I'll just give you same example. If you want to maintain this person, you have full dependency on this person, right? If the person is asking some hike, if it is asking for some vertical scaling, you have to do that because your entire project is dependent on this person, right? So it is difficult to maintain. Upgrade, this person has no time, right? This system, if this system is going to be upgraded, right, how the system will run in the time of update, right? The load has to be transferred to some other system, so it is very difficult to update, right? That's why the monolithic systems were very hard to maintain and update. And very important thing, non fault tolerant, okay. If there is some fault that is coming to this system, your entire system is going to break, right? So the world started with, let's say, monolithic systems, okay. They face these issues, okay. And now they found out the solution, okay. Please note, whatever technology upgrades are happening, it is because of some issues in the current system, okay. So monolithic system has some issues, so what happened, it, you might guess from this example, they started working on distributed systems. They started working on distributed systems, okay. Let's say I'll explain you distributed systems in terms of data storage and data processing also, right? And then we will go for these pros and cons, okay. For example, for data storage, let's say this is the master node, okay. They call it a master node. Here we had technical lead, right? And all these kind of employees are, working under him, okay. Here they call it a master node, and there are worker nodes working under this master, right? So let me just put it like this, okay, this way, okay. Fine. So all the worker nodes will report to this master node, okay. Let me just draw these arrows for all, okay. This one, then fourth one, okay, and fifth one, they are going to report. Let's say worker node 1, okay. This is worker node 2, this is worker node 3, this is worker node 4, this is worker node 5. If you know the architecture of, let's say, HDFS or something, that is fine. If you don't know, that is also okay. I'm going to tell you here in terms of data storage. Okay. So now let's say you have to store some file. Okay, there is some file, let's say it is 1 GB file, something like that. Okay, now the default, let's say this file now is going to be stored as distributed, right? So this file is going to be split. Okay, the default, they call it a block. The default block size is 128 MB, right? Default block size is 128 MB. So 128 is how many blocks for this file? I think 8, right? So one block is going to be stored here. Okay, block 2, block 3, block 4, block 5, again block 6, block 7, block 8, right? So this file is going to be stored in distributed manner. Okay, now how, let's say if I want to retrieve, okay, I send some request. Okay, from here, let's say client is sending some request. Okay, it would be reverse. Let me put it here. Let's say request. Okay, let's say I'm sending some request. Okay, now now I want to read this file. Okay, and this file is stored in distributed manner here. Okay, how I will read this as one single file? It is because of this master. Okay, this master has metadata for this file stored. Okay, this master has metadata saying the first block is stored as stored in W1, second block is stored in W2, third is W3, fourth in W4, fifth in W5, right? And each block will give their part to master, give their part to master, right? Okay, and master will do, master will combine. Okay, and master will send the combined result. Okay, so this we call, whatever master is doing here, it is called as global aggregation. Master is doing everything for global, right? So this is called global aggregation, and here we call it local aggregation in terms of processing. For example, from here I'm sending some request. I want, let's say, uh, I want to filter this file. Okay, I want all the records having some customer ID less than 10. Okay, what will happen on all these 8, I would say, blocks? It is going to filter all the customer IDs. Let's say here this 1 GB file has, for example, let's say 800 records, right? This will have how many? 200 records for this file, right? Because two blocks are stored here, right? This will have 200. This will have, just a second, 200 records for this file. This will have 100 records for this file, and this will have 100 records for this file. Okay, now what will happen first? My this first node will will work on the two partitions that it has. Okay, whatever records are there having customer ID less than 10, okay, it will send to master. Same will happen here, same here, same here, same here. Okay, so first what will happen? First it will be local processing. It will be local processing. Okay, at, let's say, at worker. Okay, and the second will be global processing at master. Okay, master will combine all the results it is receiving, and it will send to the client, the someone who is sending the request. Okay, that is how distributed systems are working. Now you will say, okay, okay, fine, that is okay. Let's say my worker file is going down. Okay, like here. Okay, my this person is going to be, is leaving the organization, but for this person there is backup over here and over here, right? So like by default, in HDFS there are three backups, there are three replications maintained for each block, right? So if this node, if this worker node has some issue, the copy, the replication, right? The backup is present in other nodes, okay? And that metadata is present at master, okay? So the first problem that was there, fault tolerance, got resolved, right? So the first pro over here is fault tolerant, okay? Then second thing, what was there? Non-efficient scaling. Here it is efficient scaling. If I want to add one more block here, okay, for this, like say, under this master, okay, it here it is having 200 records, now my this block will distribute this 100 records to the, let's say I'm adding new block, okay, new block is going to be added, okay. Worker 1 has 200, let's say worker 1 has now 100, and this, let's say worker 6 has now 100, right? If my worker 1 is taking, let's say, how many 5 minutes to process 100 records, okay, it is taking 10 minutes, 10 minutes, 5, right? Now my worker 1 will take only 5 minutes, right? To maybe instead of 10 minutes it will take 5 minutes, okay. If I add two more, workers, my entire operation is going to be completed in 5 minutes, right? So it is efficient scaling, okay, efficient scaling. And not only efficient, it is horizontal scaling, horizontal scaling, right? That's the advantage of distributed system. One more thing, parallel processing, okay. Let's say my 100 records are taking 5 minutes, right, for processing. If I had only one, let's say only one node, okay, monolithic systems, 5 minutes for 100 records, then how many minutes for 1000 record? Let's say 50 minutes, okay. 50 minutes it is taking for monolithic system, here it is taking, let's say, 10 minutes, okay. So what it is doing, it is parallelly processing, okay. So parallel processing is enabled here, parallel processing is enabled in case of distributed systems, okay. That's the advantage of distributed system. Now distributed also has some cons, okay. What is the first thing? First thing is this system looks complicated here, right? So let's say complex architecture we can call, right? Complex, they have to coordinate with each other, right? Master has to coordinate with worker, worker has to coordinate with master, right? Here in case of monolithic system there was nothing, and everything in one system, right? So nothing like coordination or synchronization, okay. So let's say complex coordination we can call it, right, for distributed system, okay. Now the debugging is difficult, okay. For example, there is some issue that is going to happen in worker node 3, okay. We have 1 2 3 4 5 6 worker nodes, okay. So we will, it is very difficult to understand which worker node has issue, or which data, from which block the data has issue, okay. So hard to debug we can call it, right, hard to debug, right. So yes, these are the advantages and these are a few disadvantages of distributed systems. Now we have learnt about the monolithic system, distributed systems, okay. These are kind of softwares, okay, that were available. Now we are learning for data engineering perspective, okay. So whatever data that is available here, okay, we will need some processing unit to process this data, right. This data has to be processed by someone, so that my worker will send output to master, right. This one will send output to this one will send output to this, right. So the first processing, I would say, software that got introduced was MapReduce, okay. MapReduce basically used to uh, I would say process it in distributed manner, okay, and send the output to master, right. So I don't want to save this, okay, fine. So MapReduce was the first to got introduced. Now I'll quickly tell you what are the pros and cons of the MapReduce when it got introduced. The first thing is it it could handle, right, massive amount of data, and that was a revolution, right? That's how big data came into picture, right? As data demands went on growing, MapReduce took birth, right? Now, second thing, it is fault tolerant. Why? Why? Because it is on distributed architecture. It was working on distributed architecture, right? That's why it is fault tolerant, right? And the hardware for MapReduce was cheap, right? So it was not so costly, right? Those were the pros, I would say, pros of the MapReduce. Okay. Now, MapReduce also had got few, I would say, disadvantages, right? This disadvantages were whatever MapReduce had to process. Okay, it will read from here. Okay, for example, this is the disk. This is the disk from which, let's say, my MapReduce will read, right? This is my disk. For every read, MapReduce had to write back the results to disk, because MapReduce has no kind of in memory processing or something like that, right? For every processing, for every request that was going to MapReduce, it used to process, and it used to write it back to disk, right? Again, this is going to MapReduce, again it is writing back to disk, right? This way. So there were a lot of disk ios, right? Lot of disk ios were there, right? That was making it a little difficult for processing, right? Taking more time. Again, reading from disk, writing to disk takes a time, right? Next thing is the, let's say, for simple things, also for simple things, MapReduce code was complex, because I think this code was used to be written in Java, right? So code was very complex for MapReduce. For example, let's say filter, right? Now you all, I think you must have gone through the PySpark series that we are, that we have completed. So what we do for filter generally, we just do a one line of code. For example, like this F.col, let's say customer, right, equals to 10, something like that, one line coding, right? But for MapReduce, to achieve this simple task, it was multiple lines of coding, right? That was one disadvantage of MapReduce, and it was available, okay, only for batch processing, right? So for, there are two types of processing, batch and stream, right? So MapReduce could do only batch processing. This was the major disadvantage, okay? And also coding was very difficult, right? So we have these cons, and I have already told you MapReduce had no capacity to do some in memory processing or something, so that this disk ios will reduce, right? That gave birth to what? That gave birth to apachespark, right? These disadvantages gave birth to spark, okay? Now spark was like they call it lightning fast, right? They call it lightning fast. It is said to be 100 times faster than MapReduce. Okay, let's see, if I write a prose, okay, 100 times faster than MapReduce. So time efficient, cost efficient. Okay. Next thing, very important thing, Spark was doing in memory processing. Spark is doing, sorry, not was doing. It is currently also doing in memory processing. In memory processing means what? Let's say this is the disk, right? And this is my Spark. Okay. Disk. Okay. And Spark. Okay. And here, how many operations I have done? Let's say I have done using MapReduce, I have done 3 operations, right? So for 3 operations, I have, let's say, 3 reads from disk and 3 writes to disk. Okay. This is not the case with Spark. Spark will read once from the disk, do all 3 operations, and write once to the disk. So it has reduced the disk IO. It has reduced the IO overhead. Data is staying in RAM and speeding up the tasks, right? That was the revolution here. And next thing was Spark supports both batch and stream processing. Spark supports both batch and stream processing. And MapReduce used to support only batch processing, right? Only batch data, right? Now, MapReduce code you used to write only in Java, right? Spark code can be written in Python, Scala, Java, and R, right? So you have got multiple options here, right? And one of them, flavor, the Python with Spark, PySpark, we have already learned, right? So these are major advantages of Spark, right? And also it has one more thing called as lazy evaluation. Lazy evaluation means what? Let's say I think I have 3 lines of code. For example, first is filter, then after filter I'm doing, let's say, group by, right? And then I'm doing, let's say, select, right? Select. These are all transformations. This is narrow transformation, this is wide transformation. What is narrow, what is wide, we have learned in PySpark series already. I'll just tell you in brief. Narrow transformation is something where there is no shuffling of data that happens, there is no need of global aggregation. Wide transformation is something where there is need of global aggregation, right? So what is lazy evaluation? If you enter only these transformations for one data frame, right, it is not going to materialize the RDD part of Spark as soon as you write this. Okay, it is going to store it in execution plan in the backend. Okay, this will get executed only when you call some action. Action means what? You call some display, or you call some write, or you call some, right, any action that you are calling. Okay, or you call, let's say, show, right? Then and then only this is going to be evaluated. Otherwise, not every time this will be executing. It will execute only when you call some action, right? So lazy evaluation was one of the important advantage of Spark. Okay, now disadvantages. Spark also has some everything, every tool, every technology has some disadvantage. Okay, the very first disadvantage, it is in memory processing. So it was taking huge memory for processing, it was needing huge memory. Okay, next thing, the infrastructure, very important thing. Infrastructure needed to be managed by, let's say, expert team. So there was an expert team for infrastructure, right? If you wanted to connect to some GitHub or something, right, there is expert team. Let's say connectivity to other softwares, for example, right? Connectivity to, let's say, HDFS or any, cloud storage or something, right? It was completely handled by engineers. So infrastructure part was completely handled by engineers, right? This is the major disadvantage, because engineers were spending a lot of time and energy here, were getting very less time to develop their software, develop, work on data engineering, right? So yeah, these were disadvantages of Spark that gave birth to DataBricks, right? So first was MapReduce, then came Spark, and then came, and this MapReduce, Spark, and Databricks, all three are working on distributed architecture only, right? It is the enhancement in distributed processing, right? Now Databricks, right? So fine. Databricks is said to be, let's say, 5 times faster than this version of Spark is called, let's say, plain vanilla version of Spark. Plain vanilla Spark version, right? It is 5 times faster. It is optimized that way, right? Now, the major advantage of Databricks. Let's not go into pros and cons. I'll tell you, it is fully managed clusters, right? You don't have to manage the infrastructure, STRU, right? Don't have to manage any infrastructure. You just click the button and you have cluster ready to use, right? That was major advantage of uh, it was game changer basically, right? Now data engineer, what they have to do, they have to learn how to, what kind of cluster they want, right? And start using that cluster, write their code, start writing the code in let's say on very first minute they start developing the application. That was revolutionary, right? And these clusters are auto scaling, right? So if you want to scale this cluster, that option is also available in Databricks, right? Another thing, there are n number of advantages. It supports it supports, let's say, ACID transactions. Okay, if you have any inserts, updates, deletes, or something like that, Databricks supports that. How it supports that, we are going to learn in all the details, right? In case of Spark, you had to do, your own coding. Okay, engineers had to do coding for this ACID support and all these things, and it was very difficult, right? Databricks has integration with cloud storages, right? All cloud storages. It has integration with, let's say, github github Bitbucket. It is already, integration is in place, you just have to connect. Okay, then let's say Azure DevOps or any other DevOps, right? It has integration already in place. Then you can connect with any database. Okay, connect with database through Databricks connectors, right? In case of Spark, you have to do configuration by yourself from scratch. In Databricks, you just connect and start ingesting or using that data. Okay, and it is, again, it has some collaborative, let's say, notebooks in Databricks. Your 10 data engineers are working together. If they want to collaborate on some code, very easy to collaborate, right? So that is Databricks. Now you will say, okay, Databricks is like something different from Spark. It is 5 times faster than the Spark, right? No, the simple definition of Databricks is, it is Apache Spark only. Apache Spark, designed and optimized. This is most important. Optimized to work on cloud. Databricks is what? It is a Spark only, designed and optimized to work on cloud. So it is, Databricks is available on all three major clouds. Okay, AWS, Azure, and Google Cloud. Right now, yeah, these are advantages of Databricks. There are many things nowadays. Databricks has integration with Gen AI, right? You can start developing your Gen AI models also here, ML models also here in same application. once I show you Databricks and Databricks UI, you will be able to understand data engineers who all can work here. Data engineers can work here. Data analysts can work here on same tool, right? ML engineers, ML engineers, right? AI engineers, AI engineers, business stakeholders, right? Business stakeholders. Why business stakeholder will work? They'll have some dashboards, right? They'll just access some dashboards, right? So all these people will work in same application. It is kind of a house to entire flow of data from start to end, right? That's why Databricks is game changer. Okay, that is the reason we are learning Databricks. And what was the purpose of explaining you everything? What was monolithic, right? Giving this example, right? This is the example we face, most of the times in our project. There is one person getting bombarded, right? And he is getting overloaded, getting frustrated, not able to work. That is simple analogy of monolithic systems. If you do it, let's say you do vertical scaling, you add salary to that person, he is going to be frustrated, right? Okay, so that's why I gave this example. And why we learned monolithic? Because we wanted to understand the importance of distributed systems, and this map reduce, spark, okay, databricks, right, all are working on distributed architecture, right? That's the reason we learned monolithic and distributed, right? I tried to explain you this in a short. I know this distributed, data storage and distributed processing is something which I tried to explain you very quickly, right? Because the motive here is to understand why we are learning Databricks, and through that I just tried to make you understand how distributed systems work. Most of you might know this. If you don't know, that is fine. This is how it works for storage and processing also. Okay, fine. I think that's all, right? I hope now you are convinced. I think at least after seeing this, okay, that yes, Databricks is a game changer currently in the market. And that is the reason, from I think next session only, next video only, we are going to start, you know deeping dive into Databricks. Okay, and on this channel, I'm not going to put videos like very basic, and then you have to learn something from advanced. No, from very scratch till very advanced, all the theory plus practical, everything I'm going to put as part of this Databricks Zero to Superhero series, right? Fine, that's all. I'm very excited to start this new one, right? It is giving me a lot of learnings, okay, for myself also. And I'm very happy to pass on these learnings to all of you, right? Fine, keep learning. And if you have any suggestions, do let me know. Fine, that's all. I'll see you in the next video where we will actually start working on Databricks. Okay, thank you so much.